Okay, in this tutorial we're gonna interact with the chain directly from the CLI, so the project code will send transactions to the chain using our wallet's private keys that we set in the .env file. So first of all, we need to set up our RPC nodes. For this, we have a lot of options. You can use a public provider that you trust, for example Cloudflare is a popular one for Ethereum, and Polygon as an official RPC node that you can use. Or you can also use a service like Infura in order to have better performances and dedicated resources. In my case, I'm gonna use Infura, so I created an account using the free plan, and I also created a project for contracts management. You can create a new project simply specifying the product type and the name for the project itself. Ethereum here works for any EVM-compatible chain. The project settings allow me to get the endpoints for each network, so I can copy the HTTP endpoint for both the mainnet and the testnet. You can paste the values to the env file to the corresponding network variable. If you're using Polygon, you can also use the official public nodes. You can go to the official documentation here, under the network details and network, and you can find the URLs for both the mainnet and the testnet. Next, we need the private keys for our wallets. Please pay attention while doing these, and also remember that here we must use the private key of one specific wallet, not a seed phrase. For example, MetaMask allows you to get your private key by entering the account details page and exporting it by entering your password. It usually returns you a private key which is not starting with the 0x prefix. You can simply add it manually since the format is exactly the same. I assume the collection configuration is ready from the previous video, so we can take a look at the available commands from the package.json file. So we have commands like deploy, verify, we can open and close each sale, and we can also reveal the collection. As you can see, there is no way to withdraw the funds or do some other advanced operations from the CLI, but I'm gonna explain all about this later. So let's deploy our contract to a real network. But before we do that, please make sure that all the configuration files are saved. For example, you can see that I have a white dot here, so this means that the file is not saved. If I close this without saving the changes, and I open it again, you can see that this is not the correct name. Deploying the contract before saving the file would deploy it with this name, and I can't change that later. And also, if I save the file after deployment with a new name, then I won't be able to verify the contract. So make sure this is saved with correct data. Now there is no white dot here, and we can also close the file. Now we can deploy our contract. I open a terminal, and I move to the smart contract folder. I already installed the dependencies using Yarn from the previous episode, so now I can simply run the deploy command. It is yarn deploy --network, and here you can specify the network name. In this case, it's testnet. This command will run the required transactions directly, and we will get back the contract address once everything is confirmed on the blockchain. So here is the contract address, and we can copy it and update the collection configuration. Now we can also go to the Block Explorer and check out the deployed contract. So here it is. But it's not verified yet. So let's do it. We have to run yarn verify the contract address and then --network and your network name, testnet in this case. And now we have to wait for the verification result. Please keep in mind that this process might fail, and it may fail for two main reasons. One, you deployed the contract with some configuration values, but then you changed them, and now the values don't match anymore. This won't work. You must leave your configuration as is at least until you verify the contract successfully. Otherwise, you might end up with a broken contract. 2. You are probably verifying on the testnet. And that sucks sometimes. Depending on traffic on the Block Explorer, you might bump into a resources bottleneck, and your verification requests will fail. If you're absolutely sure that you didn't change any configuration after deployment and the verification process fails, then you should just wait and try again later. You should always take your time when doing these things, no need to rush. And also remember that you don't need to have the contract verified in order to go on with testing. And now we can run the dev server in order to test the dep. So first of all, I'm gonna split the terminal. Then I move to the minting dep folder and I run yarn dev-server. And I can open the URL here. Here is the minting dep. Let's connect the wallet. Of course, the contract is paused, so let's open a whitelist sale. The command is simple. I type yarn whitelist-open --network and then the network name. Here is still testnet. We can see that some transactions are running automatically, updating the root hash for the Merkle tree, and also enabling the whitelist sale. And the script is gonna tell us exactly what's happening, step by step. Once done, the sale is open and we can verify it from the dep. I'm also in the list, so I can mint one token. I can check all the data from MetaMask and confirm the transaction. Now I wait for the notification from MetaMask, which is popping on my other screen. And once I receive it, I can refresh the page and I can see that one token has been minted. Cool! Now let's close the whitelist sale. I run yarn whitelist-close --network and the network name, testnet. Each command related to collection management works exactly the same. There are no arguments to be passed since everything is already set in the collection configuration. And whenever you're ready to work on the mainnet, you just have to replace the network name from testnet to mainnet. There are just a few actions that are not supported by these scripts. Some of them are withdrawing the funds and also minting to a specific wallet address as a collection owner. I'm gonna explain how to do this in the next episode about how to interact with the contract using the block explorer.